Okay, so this video is going to be about factorizing a difference of two squares. Now I know a lot of students have problems with this, so I'm just going to go through a little bit through the ins and outs of solving difference of two square type factorizing problems. But first of all, I'm just going to talk a little bit about the basics of factors. So if we look at this number 45, we see that it's the same as 9 multiplied by 5. Therefore we can say that 9 and 5 are factors of 45. In a similar manner we can find the factors of algebraic expressions like this one here. 5x plus 10 is the same as 5 times x plus 2. So here we have two factors of this expression. When we multiply them together we get the original expression, 5x plus 10. 5 by x, 5x, 5 by 2, 10. Okay, so that's all well and good. We know now that it's possible to have factors of algebraic expressions, but how do you actually find out what these factors are? Well, there are four methods of doing this, and the first method that you should always try is called the highest common factor. Now in this situation we can actually use the highest common factor, so I'll briefly explain how we did this. So 5x and 10 are two terms. What you've got to do is see if you can find the highest common factor between these two terms. So you start off, you look at the numbers 5 and 10. What number goes into both 5 and 10? What's the highest number that goes into both 5 and 10? Well, that would be 5. Then you look at the letters. Well, here we've got an x, but there's no letters over here, so there's no common letter. So we can just ignore the letters and just take 5 as the highest common factor. So 5 is the highest common factor, we put it out here, then we draw a set of brackets, and in here how do we calculate this? Well, we just simply divide 5 into 5x, we get x, 5 into 10, we get 2. And as you can see, when we multiply these out, we get the original expression. So that's how you do a highest common factor. Now unfortunately you can't use this in every case. So there are three other types of factorizing that you need to know about, and they're called factorizing by grouping, quadratic factorizing, and difference of two squares factorizing. So this video, as I said, we're just going to talk about difference of two squares. Okay, so this is what a difference of two squares looks like. You've got a square on the left, a square on the right, and a minus in between. So the clue is in the name. Difference of two squares, you need two squares, a square on the left, a square on the right, and a difference, which means minus. So in order to have a difference of two squares, you need to have it in this form. This is very important. You can't really get away without doing this. Okay? So some of you may not know what squared means, so I'm just going to briefly talk about that. So any number squared is that number multiplied by itself. So for example, 3 squared is 3 times 3. 4 squared would be 4 times 4. 5 squared would be 5 times 5, and so on. Okay, so in this case, 3 squared is equal to 3 times 3, which is equal to 9. So what we could have done was we could have wrote this expression in this form, 4 squared minus 9. Now that is the same as this, but it's not a difference of two squares. So that's important to recognize. If you want to change that to a difference of two squares, you've actually got to change this to a square, which would be 3 squared. Take this expression here, 100 minus 4. If we want to make that into a difference of two squares, we've got to do some changes, right? So we've got to change 100 to a square. So most of you probably know that 100 is the same as 10 squared. Now if you don't know that, you can use your calculator and find out what the square root of 100 is, and that will give you whatever needs to be squared. So in this case 10 squared. And here you can change the 4 to a minus 2 squared. So now we've converted this expression here into a difference of two squares. So always remember that you have to have two proper squares on the left and one on the right. Okay, so let's add letters into the mix. So you got the term here 16x squared. Now that may look like a square to you, but in fact it's not, because what's being squared here is just the x part. 16 is not being squared. So if we want to change this into a proper square, we've got to do something with it. So we're going to get the square root of 16, which is 4, and then put a square up here. So what this means is, because we put the brackets around the 4x, it means that the square is not just working on the x, but it's also working on the 4. So that is exactly the same as 4 squared is 16, x squared is just x squared. So it's the same as this term here. So that's important to know. So look at this expression here. How do you think we'd convert this into a difference of two squares? Again, you got to recognize that what's being squared here is just the x. So we got to change this expression, just like we did here, to a bracket 4x squared. And similarly with the term on the right, got to change that because the 9 isn't being squared here. So we're going to change that to bracket 3y squared. So now we've got it in the correct form. This is a difference of two squares. Square on the left, square on the right. Okay, so that's the kind of hard part of solving difference of two square problems. Next we're going to talk about actually factorizing the expressions. So for example, this is a very simple one here. You've got x squared minus y squared. So if we want to factorize this, we're going to use a very simple formula. So we get our two sets of brackets to represent our two factors, and then on the left here we're going to write in what's being squared up here, x. What's been squared here, y. And we're going to put a plus in between them. We do the same thing again here. What's been squared here, an x. What's been squared here, a y. And then just put a minus in between. Yeah. So that in fact is our answer. So these are the factors of this expression. And you can always test that out by multiplying these two guys out. So that would be the same as x by x minus y plus y by x minus y. So that would be x squared minus xy plus xy minus y squared. And if you notice that these two guys will cancel each other out, minus xy plus xy cancel each other out, so you're left with x squared minus y squared, the original expression. So we know that these two are actually the factors of this original expression. Okay, so that was easy enough. Let's try a slightly different one. So here we've got x squared minus 4y squared. Now the problem with the 4 here is not being squared, so we got to change that to x squared minus bracket 2y squared. So now we've got a difference of two squares, a perfect difference of two squares. So now we can just simply apply the formula. So again, we do our two sets of brackets. What's been squared here? X. What's been squared here? Well, whatever is inside the bracket, so it's 2y. And we put a plus between them. Again, what's been squared? An x, 2y, and put a minus in between. And that's your answer. So let's try just one more of those types. So again, if you look at this expression, you see that the 9 here is not being squared, so we're going to change this so that it's a proper square. Similarly with this 25 is not being squared, so we've got to change it. So we're going to change this one to 3a squared minus square root of 25, 5b squared. Okay, so now we have a difference of two squares, so we're ready to apply the formula. So what's been squared here? What's inside the brackets? 3a. 5b plus 3a 5b minus, and that's your answer. Okay, we're going to look at a slightly different type of problem here. Your immediate instinct might be to go and find the square root of 3 and 12 and then put brackets around it, just like we did in the previous examples. But of course you can't do that because there's no whole number square root of 3 or 12. So some students might panic a little bit when they see this and think, you know, there must be something wrong with the question, because normally what you can do here is find the square root of those two numbers, and it's simple enough after that. But if I bring you back to what I said at the start of the tutorial, whenever you're faced with a factorizing problem, you should always try highest common factor first before you try any other types of factorizing. So in fact, you can actually get the highest common factor of these two terms, because the number 3 goes into both terms. So I'm going to put 3 here, and 3 goes into 3x squared, x squared times. 3 goes into minus 12y squared minus 4y squared times. So now if you notice, within the brackets we have something a little bit more familiar. This looks very like a difference of two squares. All we need to do is change the 4 here to a 2 and put brackets around the 2y. So we're just going to do that now. Right, so that now we're very, very close to getting a solution, because we have actually a difference of two squares within the brackets. So what we're going to do now is apply the formula to this part. We leave the 3 as it is, and we're going to put two sets of brackets now instead of the one large one, and we're going to put in here what's being squared, x, what's being squared here, 2y, and a plus, and similarly here, x, 2y, and a minus. Okay, so there you see it is actually possible to have more than two factors in a factorizing problem, and it's also possible that you might have to use more than one method of factorizing to solve that problem. Okay, so just to finish off our video on factorizing a difference of two squares, and this is a special case of a difference of two squares. Some of you might not think that it is one, but in fact it is, because it satisfies the conditions. First of all, you have a square on the left hand side, and this 4 can easily be changed to a 2 squared. So in fact we have a square on the left and a square on the right and a minus in between, so that means it is a difference of 2 squared. So I'm just going to rewrite that. So now we have a difference of two squares, so we simply apply the formula. So this time we might make the set of brackets a little bit bigger than normal. So first thing we ask ourselves is what's being squared here. So what's being squared is what's inside the brackets, which is 2x plus y. And what's being squared here? 2. So we put a plus between them. And do the same thing now. What's been squared? 2x plus y. What's been squared here? 2. And now we put a minus between them. So a plus and then a minus. So that's in fact the answer to this. And don't be put off by the fact that there's more than one term in brackets here. In fact, there could be any amount of terms within the brackets, as long as they're all being squared. Then it satisfies the condition that you have a square on the left hand side and also a square on the right hand side. Therefore it is a difference of two squares.